In number 6, we are required to find the equation of the tangent to the curve at the given point. So basically, to find the equation of the tangent, we need the gradient of the tangent at that given point, which implies that we have to start by finding the gradient function, or dy over dx. So of course, to find dy over dx for this equation, which is defined implicitly, we'll have to start by differentiating term by term. So starting from the left, we have d over dx of x squared minus the derivative of y squared, which should be equal to the derivative of 9. Now at this point, well, if you the derivative of 2x squared is just 2x, and now here for the derivative of y we use chain rule. So um, you start with the outside, which will be 2y, and then derivative of y is just dy over dx, which will be equal to 0. So we end up with dy over dx being equal to this is just y, so dy over dx will be equal to negative 2x over negative 2y, which is just the same as y over x, sorry, x over y. Okay, so which means that we can be able to find the gradient of the tangent at 0.54. So at 0.54, gradient of the tangent will be equal to 5 over 4. Now that we have the gradient of the tangent and we have the point where this tangent is passing through, we can be able to find the equation of the tangent. So y minus y1 is equal to m into x minus x1, the point slope formula. And x1 is 5, y1 is 4, so y minus 4 will be equal to 5 over 4 multiplied by x minus 5. And therefore, that will be equal to, we have y minus 4 will be equal to 5 over 4x minus 25 over 4, which implies that y will be equal to 5 over 4x minus 9 over 4. And if you add these two, you end up with 9 over 4. So that will be the equation of the tangent to the curve at 0.54. Moving on, number 7, we are required to find the coordinates of the point where the gradient is 0 on this curve. So to do that, what we have to do is, first of all, we can start by finding the gradient function. So, and we can find that by differentiating this function term by term. So d over dx of x squared plus d over dx of y squared minus d over dx of 6x minus d over dx of 8y will be equal to the derivative of that. Okay, so let's start from the left. This will be 2x plus 2y dy over dx minus 6 minus 8 dy over dx, which will be equal to 0. And then we can collect like terms together, the dy over dx's. So basically we'll have 2y dy over dx minus 8 dy over dx will be equal to 6 minus 2x. And then you can factorize out 2y minus 8. and then which implies that dy over dx will be equal to 6 minus 2x over 2y minus 8. Now, once we have that, what we can do is proceed to this condition. Now, this condition states that um, basically the gradient, the point where the gradient is 0. So the point where the gradient is 0 means that dy over dx should be equal to 0 at that point because the gradient is 0. So when this is equals to 0, I mean, if you solve this equation, this multiplied by 0 will just be 0. So we'll have 6 minus 2x being equal to 0, which means x will be equal to 3. So at that point, x will be equal to 3. So we can now proceed and say, well, when x is equals to 3, what will be the value of y? So at x is equals to 3, we shall have this. If you plug 3 in place of x, so 3 squared will be 9 plus y squared minus 18 minus 8y will be equal to 0. So basically, the resulting equation is y squared minus 8y minus 9 will be equal to 0. Now, if you factorize this, you'll end up with y plus 1 and then y minus 9 being equal to 0. So either y is equals to negative 1 or y is equals to 9, which implies that when x is equals to 3, y is either negative 1 or y is. So the points that are required here, the points where the gradient is 0, are 3, negative 1, and 3, 9. These are the points where, these are the coordinates of the points where the gradient is 0.